Cut to a computer-generated demonstration of the rainfall cycle. Jerry Trinquisir's voice in the background says, an area water supply depends on the hydrologic cycle, which can be constant over decades or centuries of time. About 30 inches of rain falls on the contiguous United States each year. Nearly two-thirds of the U.S.'s annual rainfall is consumed by vegetation, while the remaining one-third runs off into rivers and creeks and is then channeled to the oceans. Up until the year 2002, the annual rainfall of the U.S. was so high that the volume was enough for nearly 2 million gallons of pure, distilled water per person. Until recently, it was believed that there would never be a real water shortage in the United States. The problem is that so many people live in large metropolitan areas or in deserts. Urban and desert dwellers need enormous quantities of water to support their lifestyles. The rich soil and plentiful sunshine found in the desert provide two of the three elements necessary for profitable farming. Water is the third and most precious. Government agencies manipulate the runoff portion of the hydrologic cycle to meet these demands by diverting surface water to cities or for irrigation. Cut to stock video of California Valley irrigation system flowing freely. The water is running through a concrete-lined channel which ends in dirt ditches. The sun is high overhead. To the viewers, this seems like an incredible waste of valuable resources. In both cases, the amount of wasted water is high. In the cities, little water is actually consumed before being returned to the surface drainage system. In the case of irrigation, the water that is diverted for the crops is consumed by the plants by being converted into vapor by transpiration through the stoma of the leaves. In both cases, surplus water is degraded through contamination by pesticides, fertilizers, sewage, phosphates, or chemical leachants after use and is then returned to either the surface water or groundwater reservoir to contaminate the original supply. Traditionally, short-term variations in weather patterns have led to droughts. In most areas of the United States, government agencies plan for this contingency by storing surface water behind dams or transfer water from one drainage basin to another. The idea is to ensure that the total water supply won't change appreciably over a period of years. The excess water from excessive rainfall drains in a matter of days or weeks, while it may take months, sometimes years to replenish depleted reservoirs. In many areas of the country, water comes from deep wells driven into aquifers surrounded by non-porous bedrock. An animation begins showing how water is trapped in aquifers and it pumped up to the surface. The first part is a part of a stock animation on water supplies, but for the second part, the animation department had to create new files to display the different aquifers and their current state. When excessive amounts of water is pumped up from these aquifers, it may take thousands of years to replenish them. A short animation is displayed of a water droplet moving through the ground as the ecology of the upper land changes over a period of 1,000 years and civilization is built over the aquifer. Most groundwater for irrigation in the western U.S. comes from the aquifers in the Ogallala Aquifer in the southern High Plains region, the alluvial aquifers of central Arizona, and the Central Valley of California. The rapid decline in deep well water levels has proved that heavy exploitation of aquifers for groundwater irrigation has depleted the stored water in the earth. Another short animation is displayed showing the decline in the water table as the reserves are pumped out. Cut back to close-up of Anchor. In California and Arizona, surface water has had to be imported for almost 20 years, thus curtailing groundwater production. At first the groundwater levels recovered to a degree, but when the drought dried up the rainwater, the levels remained static. California's chronic water shortage provides the best-known historical example of the long-term economic and political consequences of a regional water shortage. From the 1990s on, most of the state's water has been imported to benefit agriculture. Approximately 85% of the state's water is still used by farms for irrigation. While only 10% of the state's water is given over to municipal use and the remaining 5% is utilized by industry. About half of the irrigation water comes from surface sources and half from groundwater.